Welcome to The Explainer. So, we're diving into a really radical new idea today, one that might just flip our whole understanding of the universe on its head. It basically suggests that a whopping 95% of what we think is out there, well, it might not be there at all. All right, so for decades now, the standard model of cosmology has looked a lot like this cosmic pie chart, and it tells a pretty wild story. Everything we can see, everything we can touch, you, me, the stars, the galaxies, all of that is just this tiny little 5% sliver. So what about the other 95%? Well, that's supposedly made of mysterious dark matter and an even more baffling dark energy. They're supposed to be running the whole show, but we have no idea what they are. But what if that's just not right? A really compelling new paper is challenging this entire Nobel Prize-winning idea, and it's suggesting the answer isn't some exotic new particle we have to hunt for, but something way, way simpler that maybe we've just overlooked. Okay, let's get into it. So the first real crack in this standard model is actually pretty simple. For the better part of a century, we have been looking for dark matter, and we have found absolutely nothing. You know, this whole hunt started way back in the 1930s. And then in the 70s, astronomers saw that galaxies were spinning so ridiculously fast, they should have just flown apart. So the thinking was, there must be some kind of invisible dark matter holding them together with gravity. And that kicked off decades of searching. We're talking massive experiments deep underground, giant particle colliders, the whole shebang. And the result? It's been the same every single time. Not one single confirmed detection of a dark matter particle. But beyond just not finding anything, there's a much bigger, almost philosophical problem with this whole search. And it really comes down to how we've been looking at the universe in the first place. And here it is. This is kind of the bombshell of the whole paper. All of our grand theories, this whole idea of a 95% dark universe, it's all based on detailed spectral maps of less than 1% of the universe's total volume. Think about that. We've basically built a model for the entire ocean based on a single drop of water. The source paper puts this so perfectly. It talks about these incredible new telescopes, right? And how they've given us this spectacular, super high-resolution picture of a tiny shell of the universe around us. The problem is, we've then taken that picture and assumed the entire unobserved cosmos looks exactly the same. We're completely mistaking the map for the territory. Okay, so if dark matter and dark energy aren't the answer, then what is? Well, this new theory proposes something pretty straightforward, a simple reclassification of all the stuff that's already out there. So first up, the paper introduces this idea of baryonic obscurus. Now, that sounds fancy, but it's just normal matter. We're talking protons, neutrons, the gas, dust, and plasma that we know and love. It's just in the dark to our current instruments, either because it's too cold or too spread out, or it's just in a corner of the universe we haven't looked at closely enough yet. It's not some new exotic particle. It's just stuff we haven't managed to find yet. And the second piece of the puzzle is cosmos tenebris. Again, sounds dramatic, but it's really just truly empty space. It's not some mysterious energy field that's actively pushing the universe apart. Nope, it's just genuine, absolute nothingness between the big clumps of matter. And this simple little equation really gets to the heart of the whole idea. It says the total gravitational mass that we observe out there, the m-graph, is just the sum of the visible normal matter we can see, the b-vis, plus all that hidden, obscured normal matter that we haven't seen yet, the b-ops. That's it. No new physics, no magical particles needed. So this is the big shift in thinking, right? The standard model has to invent brand new, totally exotic things to make the math work. This new model says, hang on, maybe we just need to get better at finding the normal stuff that we already know exists. The problem, it argues, isn't with our physics, it's with our cosmic inventory. We're just bad accountants. All right, so you might be wondering, if there's no dark energy, then what's making the universe expand? Well, this model replaces that mysterious push with the good old-fashioned pull of gravity, just on a cosmic scale we haven't fully appreciated. So according to this model, the universe is just this incredible cascade of gravity. Our own galaxy, the Milky Way, is getting pulled by the nearby Virgo cluster. Okay, but then the Virgo cluster is part of this even bigger flow of galaxies heading towards something called the Great Attractor. And then that whole structure, our entire home supercluster, which is called Laniakea, is itself being pulled toward the absolutely immense Shapley supercluster, which is one of the biggest known collections of real normal matter in our corner of the universe.
The analogy here is just perfect. It's like we're looking at the ocean at night. We've been staring at the white foam on top of the waves and inventing ghosts to explain why it's moving, all while completely ignoring the deep, powerful currents of the huge ocean right below the surface. This model says there's no mysterious force pushing things apart. Instead, it's just a cosmic bulk flow where everything is falling towards the biggest piles of real matter, both the stuff we can see and the stuff that's still obscured. So, this is all a great story, but how do we actually prove which theory is right? Well, the answer might lie in a technique that astronomers have been using for centuries. The final judge in all this is a technique called spectroscopy. And it's actually a pretty simple test. When light passes through something, like a cloud of gas or dust, that stuff leaves a unique fingerprint on the light, a spectral line. So if we see a spectral line, we know we're looking at normal, baryonic matter. If there's no light, no fingerprint, and no gravity to measure, then it's just a true vacuum, cosmos tenebris. The theory argues there is no third option. It's one or the other.
And this really frames the whole debate perfectly. The standard model is asking us to find an entirely new particle that doesn't interact with light at all, a mission that has failed for decades. This new theory, on the other hand, is just making a bet that our inventory of normal matter is incomplete, and that eventually our telescopes will get good enough to find the rest of it. Ultimately, the paper argues that the burden of proof has completely shifted. It cites everything from the decades of failed searches to the fact that our models are based on less than 1% of the universe. And it makes a powerful case that this whole dark paradigm is standing on some pretty shaky ground, especially when a much simpler explanation, based on stuff we already know is real, is just sitting right there. So, after all that, what's the big takeaway from this cosmic debate? What does this all mean? Well, it really leaves us with this one provocative question. For almost 100 years, have we been chasing cosmic ghosts? Have we been filling the vast darkness of space with these hypothetical entities that were just born from our equations? Or is the darkness just dark? Is it filled with either true, absolute emptiness or just with regular old matter, waiting patiently for us to turn on some brighter lights and finally build instruments powerful enough to see what's really been there all along? Thank you for joining us.